Hello everyone. So here is a problem on hexagon. Let me read the problem. A hexagonal lamina of sides 25 mm rests on one of its corners on HP. Okay. The lamina makes 45 degree to HP, and the diagonal passing through the corner on which it rests is inclined at 30 degree to VP. So draw its projections. So by reading this statement, diagonal passing through the corner, it is understood that it's a problem with beta angle. Hopefully we'll get a beta angle. So initially we have to draw XY line as a part of solution. So I have already drawn it and I have already located VP, HP. Now we have to construct hexagon in its initial position, and it's a corner resting, right? So now corner resting means both the sides corner will come, since it has got even number of corners. So perpendicular to that we'll get a side. That means in the above part and the below part will get side, in both left as well right will get the corner. So that is why let me draw the line like this first. 25 now, so exactly 2.5 box in your grid book. 25, right? So now we have to measure the angle. So what is the angle in case of hexagon? So hexagon means the overall angle is 360 degree, and hexagon has got how many corners? 6. So 6 corners, 360 by 6 is 60 degree. So each angle in a hexagon is 60 degree. In case of pentagon it was 72, right? So here it is 60 degree. So now let me measure the angle. Yes, this side I'll consider it first. So 60 degree this way as well. From one more corner we have to measure it again. It is 60 degree, right? So draw two thin infinite lines, and then taking the compass, measure 25 mm, and then cut the arc on these two infinite lines. 1, 2. So now we got 3 sides, right? So now one more time we have to measure the angle. So what is the angle? 60. So keeping my protractor here, I'll measure the angle 60 this way from this side. So it is 60 here. So now draw one thin infinite line, and now cut 25 mm on this again. So I'll get one more corner. So from this corner again cut an arc, and from this another corner again cut one more arc. We'll get one more intersection. That would be our last corner. So now join all the corners. Join it like this and increase the thickness of all the corners here. Only the hexagon part should be thick and everything else should be thin. All the projection lines I'm talking about. Yes, so we got the hexagon like this. So now let me name it. This should be our A, B, C, D, E and F, right? So this is the first position of corner resting. So corner is towards our left. Okay, so now to get its front view, project all the corners. So this B and F will get it in the same line. Similarly this C and E will get it in the same line, and D like this. So now we just increase the thickness here. So because it's our front view. Now we can completely see A. There is no disturbance here. So this will be our A dash. Here B and F are on the same line. From front we can see only B. We cannot see F because F will be hidden because of B. So B dash outside the bracket and F dash inside the bracket. Similarly here we can see only C. So C dash outside and E dash is hidden, so it will be inside the bracket, and here D dash, which is visible, so it will be outside the bracket. So we got even the front view in the first position. So next he is talking about 45 degree to HP. So inclination with respect to HP can be seen in VP, right? So now we have to measure for 45 degree. From here let us measure 45 degree. So where is 45? Here it is, 45 degree. Draw one thin infinite line as we always do, right? So now take your compass. First measure A dash to B dash F dash. Cut the same on this line. Next measure A dash to C dash E dash. Cut on this line. And next measure A dash to D dash and cut the same on this line. And now you can increase the thickness of even this line. What is the inclination you have given? It is 45 degree, no? It is 45 degree. So now it is our A dash, and this is my B dash F dash. Here it is C dash E dash, and this is my D dash. So we got the third view. Now we have to project it downwards. Project it downwards. Thin lines, projection downward, and projection downward. Make sure that all the lines are thin, and from this project every corner forward. 1, 2 and 3. Okay, so now we have to search for the common points. So A and A are meeting here, so this will be my A, right? B and B are meeting here, so this will be my B. C and C are meeting here, so this will be my C. D and D are meeting here, so this will be my D. E and E are meeting here, so this will be my E. And at last F and F are meeting here, so this will be my F. So there is a correction here, so this is not my B, this will be my B, so because B and B are meeting here. So correct it. So this is how we can get this, right? Yeah. So now we can join all the corners, A to B, B to C, C to D, D to E, E to F, and F to A at last. So now even the fourth position is done. So here A to D is what? It's a diagonal passing through the corner on which it is resting. That is what he is talking in the problem. Diagonal passing through the corner on which it rests. So here there is one more diagonal, of course, in the fourth position. So see, what we can observe here is this diagonal and this diagonal. Are they same in dimension? No. The dimension is being decreased here, right? And in the problem statement he is telling it's a diagonal resting on the next inclination. Since there is a reduction in length, we have to go for beta angle. So now hope you know how to take beta angle. So first we have to consider the given angle in the problem. So he has given inclined to 30 degree at 30 degree to VP. So inclination with respect to VP can be seen in HP, right? So now let me consider the 30 degree this way. So measure 30, this will be the 30 degree. Okay, so now draw 30 degree line first, thin line, right? 30 degree line. Next what we can do is, first we have to consider this AD from the first diagram. Okay, so AD, measure it. So now you can simply locate point A here, and then cut for D. Measure A to D and you can cut for D. You got it here, no? So now from this point a line should pass through this point, and that line should be parallel to XY line. Okay, so I'll draw a line from this point, and which is also parallel to the XY line. Okay, right? So now we have to measure this AD in the fourth diagram. Okay, measure this, keeping the compass on A. We have to cut for D here, one more D. Understood? So now we have to join this. So this is how we have to consider beta angle. So now this is my D. Hope you understood, right? So now keeping A and D as two reference points, we have to cut for all other points. So now let me measure for DE first. D and DE. So DE and then AE. So A to E will get it here. So it is not touching XY line, thankfully. That means it should not touch XY line. No, it will touch XY line here. No, it is not touching. There is a gap. Yeah, fine. Make sure that this point, this E point I am talking about, it should not touch XY line. It should be well below XY line. Plan like that and you can then consider. And next I'll consider the point A to F, and next D to F, and E to F. So got it? Similarly, A to B, A to B. Yes, so cut it here, A to B. Also D to C is equal to A to B, right? So D to C, cut it. And then consider D to B. And one more thing here is D to B is equal to A to C. So first cut D to B and then A to C. So we got all the four intersections, right? So now join all the points A to D. So first D to E, and then this is my point E. Okay, and then E to F. This is my point F. Okay, and now from F to A, here this is my C and this is my B, right? So A to B, D to C, B to C. A, B, C, D, E, F, and it should be well below XY line. So if you can observe here, there is a gap. It is not touching XY line. So when you do also, it should not touch XY line in such a way that you have to plan for it. Okay. So now we have to measure the beta angle. So this is 30 degree row. We have to measure the new angle, and that will be the beta angle. So let me measure it. It is 44 degree I am getting. So beta angle is 44 degree. So 1 or 2 variations are fine. It should be 44 or 45 on and around. Okay, so now easy thing, you have to project it upward, each and every corner. Make sure that the projection lines are thin. Project it, and here project it forward, and project it forward. Okay, so now locate the common points. A and A are meeting here, so this will be my A dash, right? Next, B and B are meeting here, so this will be my B dash. C and C are meeting here, so this will be my C dash, correct? This will be my C dash. D and D are meeting here, so this will be my D dash. E and E are meeting here, so this will be my E dash, and at last F and F are meeting here, so this will be my F dash. So now join for all the points. A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, E dash to F dash, and F dash to A dash at last. So this is the final view of the problem. So the beta angle is 44 degree, or it is approximately 45 degree. Hope you understood this. Thank you.